Hello everyone, in this video let's discuss about transistor as switch. If you are new to our channel, please subscribe for more engineering related topics. So when we are discussing about transistor as a switch, these transistors which we are using to make it use as the switch, these transistors are the basic building block of electric circuit. Basic building blocks of electric circuit. Now we can use these transistors as switch, we can use them as the switch, we can use them as the amplifiers, and many more. So if we are using this transistor as an amplifier, we must be knowing that these transistors must be in active region. If the transistor are not in active region, they cannot be used as the amplifier. If they are in the active region, we can use the transistor for amplifying operations. Now while discussing about transistor as a switch, there will be two conditions. That is, this transistor can be in the active saturation region. This can be in the saturation region, and these transistors can be in the cutoff region. If the transistors are in the cutoff region, they will act as a open switch. There will be no flow of the current. If the transistors are in the saturation region, they will act as a closed switch through which the current will flow and the circuit will be connected. Now let's discuss both these conditions, that is when the transistor will be in the saturation region and when it will be in the cutoff region. So in this circuit we are using the common emitter configuration. Because the emitter terminal is grounded and Vin, that is giving the input through the base terminal, the current IB will be flowing through this, and through the collector there will be the flow of IC, that is collector current IC. Now let's consider the first condition, that is transistor. Let's take the BJT, that is bipolar junction transistor, BJT in cutoff region. I already said if the transistor is in cutoff region, it will act as a open switch. Now when it is acting as a open switch, that is in cutoff region, V input value will be equal to 0. That is, input voltage will be equal to 0. Therefore, the current IB value will be also equal to 0 and current IC value will also be equal to 0. That is, when input voltage value will be equal to 0 in cutoff region, both junction, that is what are the two junctions right here? BE junction, that is base emitter junction, and collector emitter junction, because we are taking the common emitter configuration. So base emitter junction and collector emitter junction will work in reverse bias condition. When they will work in reverse bias condition, there will be no conduction of the current or the flow of the voltage through them. Therefore no progress will be attained. So as these consequences occur, there will be the drop in voltage, that is voltage drop will be high. Due to this high voltage drop, it causes the transistor circuit to be open switch. Transistor circuit will act as the open switch. Now let's discuss about the second condition, that is BJT or any transistor, bipolar junction transistor in the saturation region. I already said earlier that when the transistor will be in the saturation region, it will act as a closed switch. It will act as closed switch. So here the input, that is voltage input, will not be equal to 0. It will be of the positive pulse. Therefore, when positive pulse, that is positive input, is given to the input side, then the base terminal, that is base terminal where we are giving the input, base terminal will produce larger current, will produce large current IB, because at the base terminal if you apply the input, therefore the current will be produced will be IB, that is IB value will not be equal to 0, it will be large current. Therefore the BE, that is base emitter junction, and the CE, that is collector emitter junction, will be forward biased. When the two junction, that is base emitter and collector emitter junction, will be forward biased, there will be large production of the current, large production of current. What current? That is IC. The collector current will increase as the base emitter and collector emitter junction will be forward biased. Therefore the voltage drop will decrease. Therefore the voltage drop will decrease. Therefore the transistor circuit, will act as the closed switch, will act as closed switch. So the voltage drop across VCE, because the VCE is there, no, collector and emitter, voltage drop across VCE will be small, around 0.2 volt to 1 volt in the case of bipolar junction transistor in saturation region. Hope you understood the concept of the transistor as a switch. If they give in the exam, write this circuit and write the theory part what I wrote here, and write the BJT in the cutoff region and assign the value of the input voltage is equal to 0, IC value 0 and IB value will be 0. So redraw the structure, that is redraw the circuit for the BJT in cutoff region, and again redraw the same circuit for BJT in saturation region, where IB value will be more and IC value will be not equal to 0, that is IC value will also increase, and V in value, that is input voltage value, will not be equal to 0, it will be of the positive pulse. So hope you understood the video of the transistor as a switch. If you have any doubt, please comment below. If you like the video, don't forget to subscribe. Please support. Thank you.